All right, so welcome to Managing Machine Learning Experiments with MLflow. We're going to start off with a quick round of introductions. My name is Brooke Wenig. I lead the machine learning practice team at Databricks. Our team is a hybrid of professional services and training, but focused on data science. And I'd like Jules to introduce himself, my partner in crime.
Hello, thanks a lot, Brooke. My name is Jules. I'm a senior developer advocate at Databricks. Been here for about 4.5 years, and I do all the advocacy efforts for not only MLflow, but also Spark and other open source products. So really proud and delighted to be part of this conference today. And Toronto is my favorite city, so love to see all these people from Toronto.
And it's one of my favorite cities as well because my boyfriend's from Toronto.
Lovely.
All right, so here's the agenda for our talk today. We're going to start off with motivation for why managing your machine learning experiments is needed these days. And then the four main components of MLflow: tracking, projects, models, and model registry. And then Jules will finish off with a demo. He is strategically doing the demo as I sliced my hand and cannot code this week. All right, so I would love for all of you to share in chat about how do you currently track your data science experiments? Do you have a shared Google Sheet that all of you put your experiments in? Are you checking into Git with your experiments with a config file? Are you using your file names like _final, _lr, _point2? How do you all track your data science experiments? Use PyCharm and Git. We've got some PyCharm lovers here.
Napkins. Brilliant. I think that's very innovative. I love it.
So you can start to understand the problem where that breaks down. Maybe you forgot what parameters that you had set for your experiment, or it's given that we're all physically separated from our coworkers, it's not very easy to share your napkins with others. So then the next question, how do you allow others to reproduce your experiments? Let's say that you just have import TensorFlow in your code. How do they know which version TensorFlow that you used? All right, Andrew's already cut to the chase in the process of replacing MLflow.
Conda ML, that's good.
And so let's take this one step farther. How do you manage your models across various frameworks, languages, algorithms, etc.? Let's say today I want to deploy a linear regression model with scikit-learn, but tomorrow I want to deploy CNN with TensorFlow. Actually, that example doesn't make sense. Linear regression going to fully connected neural network with TensorFlow. How do you have the DevOps team change which dependencies that you have, languages, etc.? And then lastly, how do you version and deploy these models? How do you make sure that you have a good process for rolling out from staging to production to archived? And so this is where MLflow comes into the picture. It's an open source machine learning platform. It works with all of the popular machine learning libraries and languages. So it supports Python, Scala, Java, and R right now. It runs the same way anywhere, whether you want to run it on the cloud or locally, and it can scale to organizations of any sizes. And so what's really nice about it being open source is that companies and individuals no longer have to maintain their own brittle infrastructure to be able to track and reproduce their machine learning experiments. And it's very easy to get started with. You simply need to just run pip install MLflow. And so MLflow has four main components: tracking, projects, models, and model registry. And we'll dive into each of these in more detail later. But at a high level, MLflow tracking allows you to record and query your experiments. So this is keeping track of the code, the parameters that you'd set, the metrics, tags, etc. MLflow projects allows you to package up all of your code, and you're able to redeploy that code on any other platform. MLflow models allows you to standardize your model deployment. So for example, I just call MLflow load model, and it will load in my model, whether it's a Spark ML model, scikit-learn model, etc. So it's a generic format that allows you to standardize your model process. And then lastly, we have MLflow model registry. This is what allows you to track, version, and roll out your models in a very centralized manner. So let's dive into each of these in a little bit more detail. So some key concepts in MLflow tracking. These are all of the different things that you can log. You can log your parameters, metrics, tags, artifacts, etc. And whenever you track your code, it's logged as a run. That's an instance of code that is run by MLflow. Runs are then aggregated into experiments. So for example, I could have an experiment to be predict the housing price in Toronto. And I could have lots of different runs of all the different models that I try, and they're all tracked under one central experiment. So this is a screenshot of the UI. Jules will walk you through this in more depth later, but this is what the tracking UI looks like. You can see here, I created a run called random forest, the user, the source, version, And I wanted to modify the hyperparameters that I used for my random forest. I wanted to vary the max depth and the number of trees, and I can see the associated R squared here. And so if you have more parameters, they'll all show up here. You can filter off of them, search, sort, etc. So the MLflow tracking, you can log to the central tracking server either through notebooks, local apps, or cloud jobs. And you can see here all of the different things that you can log. And then afterwards, you can query it through the UI, just as I showed you there. There's also the API or the MLflow client. And now it's actually a supported Spark data source if any of you are trying to integrate MLflow with Spark. So now let's talk a bit about MLflow projects. So the motivation for why we need projects is there's a diverse set of tools that all data scientists use. Nobody will just use scikit-learn in isolation. They'll combine scikit-learn with pandas, with TensorFlow, etc. Then on top of it, there's a diverse set of environments. Maybe you want to train your models locally on a subset of your code, but then deploy it to some remote execution like Databricks. And the challenge is that it's really difficult to reproduce these. All of these have different dependencies. Maybe I'm running TensorFlow 1.14 locally, Databricks is running 2.1. How do we reconcile that? And so that's where MLflow projects comes into play. It allows us to package up our data science code in a manner that's reproducible and will run on any platform. And so with the MLflow project spec, you have your code, could be R, Python, etc. Your configurations, this is where you can specify your default values. For example, your default max depth, default train data path, etc. Data, and any dependencies that you have. For example, this is where you specify, hey, I need PyPy version XYZ. And so this is what allows you to run the same code locally or on a remote execution. And so you can see here an example MLflow project. You can see the structure. We have that kana.yaml somebody had posted in the chat about. We have our entry points and our parameters. And you can see here, we can specify our default parameters and the command that is run to invoke this project. And so you can also run projects based out of GitHub. And Jules and I have some examples that we'll show you at the end. We can give you links to about how to run remote projects that are backed by Git. And so you can see here, these are all the dependencies that you can specify. This is where you specify precisely which version that you want. This way, there's no confusion which version you use locally versus remote. So now that we've talked about how to track our models, how to package our models, now let's talk about what MLflow models, how MLflow models are represented. So like with all the other slides, we're going to have some motivation for why there is a need for MLflow models. You can see there's an N by M combination of models and popular serving tools. And so the problem is that if you standardize your infrastructure on scikit-learn, and then tomorrow you want to switch to TensorFlow, you're going to have to change all of this code for how you load the models and how you apply and transform your data, etc. Instead, if we just use the MLflow model format, this gives us a standard way to standardize across all of our models. And instead, we just call them flavors. So for example, you can have a scikit-learn flavor, a TensorFlow flavor, but the way that you invoke it is the same regardless of the flavor. So you can see here, an example MLflow model will be logged with the API like mlflow.tensorflow.log model, mlflow.spark.log model, etc. And so you can see here, it keeps track of that run ID that's associated with the run from the tracking UI we were talking about earlier. And then you can see the flavor here. This is a TensorFlow model. If it were a scikit-learn model, the flavor would be scikit-learn here. And so these are used by tools that understand the TensorFlow model format. And so even though it's a consistent API to load and to save, MLflow internally keeps track of all of the framework-specific information. And so you can see here, I'm going to have a predict method that I'm going to generate. And to do this, I'm going to call mlflow.pyfunc.load model. I just give it the path to the model. And then based off of that model format, MLflow knows which type of model I'm loading under the hood. Was that a Keras model? Was that a TensorFlow model, etc. And then I can apply that predict function to any pandas data frame. All right, and now lastly, what I want to introduce before Jules walks you through the application of all these concepts is the MLflow model registry. So I would love all of you to share on chat what your organizations currently do. How do you currently find the best version of your model? Ronald's already using MLflow, stored in Docker, awesome, using the metadata. And so you can see all of you are very proper about how you store your best version of your models, but in some instances, people rely on naming conventions in the path of the file, or they might not know that the model name has now been updated and they're using a stale model. Some other challenges are, how was that model trained? What were the dependencies? How do you track the documents for each model? So how do you keep track of all that metadata associated with it? And then what does the review process look like for models? Do I just click a button and go straight to production? Or is there any review process where it first has to go through staging, has to pass some sanity tests before it can even move on? And then how do you integrate it with CI/CD? And so this is where the MLflow model registry comes into play. You'll track all of your models using the MLflow tracking server. And then what you can do is once you've tracked those models, you can register them. And once you register a model, then you can have different versions of that model. So you can have version 3 associated with staging, but version 1 is still in production. And so with this MLflow model registry, it's a central place for you to control all of your models. And so everybody knows where the most up-to-date model is for that application. And then you can see here, the MLflow model registry can be queried by downstream users, can be used for automated jobs, for example, pushing to Azure ML, etc. And it can also be used for REST serving. And you can see here an example of an MLflow model registry for the airline delay Spark ML model. You can see here that version 1 was created by Clemens and has now been archived. Version 2 also archived. Version 3 is in production, and version 5 is now in staging. And so the MLflow model registry gives you a central repository with unique name registered models, allowing everyone to discover where those models are. And it provides all of these benefits: UI and API for registry operations, so you can do it manually or you can do it programmatically. It also allows for multiple versions of models in different stages with a consistent URI. So for example, load latest production or load latest staging. It also allows for model stages. So for example, stage transitions from none to staging to production or archived. And then you can easily load in specific versions. And this is also very good for reproducibility, because in some cases, people just push whatever the latest models into production, and they have no track record or history of what the prior models had looked like. This way, you can still keep track of them, but you're not actively using them in production. And then in addition, you have model lineage. So you can see how those models have changed over time. And you can always roll back to a given model if needed. For example, if version 5 doesn't perform as well as version 3, you can always roll back to version 3. And so now I'm going to turn over to Jules to run through a demo. This is the link to the notebooks that he's going to be running through, and I'll also post this in chat. And without further ado, I will turn it over to you, Jules.
Well, thanks a lot, Brooke, for setting the stage for this excellent. So what I'm going to do is now share my screen and walk you through some of the concepts that Brooke talked about and how it actually manifests itself in our Databricks managed platform. Now, what you're going to see today is the managed version of MLflow. Can you guys actually see my screen? Okay. Okay, brilliant. All right, so what you're actually seeing before you is of a managed platform, and the demo today is about managed MLflow, and it has some enterprise features that don't exist in MLflow open source. And the reason we actually want to do that, because we wanted to have the ability to show you and share with you that there are certain things that the MLOps operations and people in engineering actually do that require some of these things which are managed for you. And so what you actually see over here is the Databricks cloud environment with managed MLflow running. And I'm running what we call the Databricks runtime version 6.6 that has every libraries and everything that I need to run this particular model available. So I got TensorFlow installed, I have Scikit, I have Keras, and I have all the libraries and the right version of the Python installed. So I don't have to worry about doing pip install and all of that. So today's model is, as Brooke pointed out, we're going to actually create a random forest register model that actually takes in a few features that predicts what the power output of a wind farm is going to look like. And the three features are wind direction, wind speed, and air temperature. And what we're going to do is we're going to run a couple of experiments of several runs and pick up the best one that actually we feel that gives us the best metric, and as a result of that gives us the best prediction. And this is data actually that we collected from the National Wind Toolset Society, and you can actually get the data from this particular notebook. And so what I'm going to do first is run this particular thing called classes.init. Now, I normally like to actually sort of delegate and create classes that I can share with other people, that they can either extend the class and override the particular method and delegate all the functions and utilities that I actually need in this particular concept. So you might actually wonder, what is this particular run class init looks like? So let's look at this particular file over here in this particular notebook that actually has all my utilities that I'll need to run this particular experiment. And this is sort of a normal thing that I actually import from Pandas as PD. MLflow tracking client allows me to get a particular client that's going to be talking to the tracking server, and tracking server is embedded in here, so you don't have to worry about setting that environment. And these are just normal entities and other objects that I import from the MLflow library. And then here's my utilities function that I actually use. And I like to sort of create all the static methods so I can use this particular programming paradigm to delegate the task to it. So I'm going to use my load function to load things. I have my training data to get the right amount of data that I need from my data, and the training data and the dependent variables that I need. I have some methods that allow me to do the validation data, so I can actually get the exact amount of data that I need. This is a routine that actually forecasts my model given a set of data. So I'm trying to predict how my weather forecast looks like 5 days from now compared with what my model predicted. So this is all tasks and functions which are sort of dedicated, so I don't have to clutter my main notebook with all these different methods. And then I have my plot utilities that allow me to plot those things. So all these are sort of made that as part of the utility functions. And then I have my forecast application that I'm going to integrate with my model registry as part of my CI/CD process. So when I put a model in training or when I put a model in staging, I can use my forecast application to test to see what particular version of the model actually worked well. And based on that, I can either promote it to the next stage. And all it does is takes the predicted data and forecasts it, again, using the Plat UI. And then the final thing is my model. This is my random forest registry model, and I create it as a class. And now my constructor actually will take all the parameters that I need. And these are the hyperparameter tuning parameters you would use, maximum depth, number of trees, what I'm going to use, validation, all these hyperparameter tuning parameters that you actually use to tune are going to be part of this particular class. And then I have a class method called new instance, and that just returns me a new instance of this particular model. So I can use different parameters with new instances to keep track of all the different runs that I have. And then these are very Pythonic way to express my properties for my root mean square, my MSc errors. And here is the gist of what Brooke talked about. I have a method for this particular called MLflow run, and it takes the regular parameters. And these are the normal procedure that you actually go through as a data scientist to train your model. So when you actually do this MLflow start run, what essentially it does, it creates a session with the tracking server. And the tracking server, as Brooke pointed out, is running either on a remote server somewhere, or in this particular case, running on a Databricks cluster. And then these are the MLflow log parameters, Fluent APIs that they actually use to log the parameters. And over here, I'm logging all the parameters that I have, which actually came in through my constructor. I can also use MLflow log.param in the param name and the actual value. But this is a good way to sort of log all the parameters that I need. So I don't have 6 different statements to log each and every different parameter, and I can just put them in one batch. And this is your typical code that you actually use to do this, to fit the model and then do the compute the metrics. And then now I'm logging the metric, and this is what Brooke talked about, how you actually use the tracking API to log the metrics. And then finally, I log the model as an artifact, and we consider models log to be artifact. If you actually say create a PNG file, if you were doing this as a classification model, then you might create a confusion matrix PNG, or you might create the matrix called R1 square and all that. You can actually log those metrics over here, and you can log the artifacts as a PNG, or if you create, say, for example, feature importance CSV file, you can actually store that, and it will actually store that as part of the artifact. So that's what this particular class looks like. So I'm going to go back to my model, and I'm going to go ahead and run this. And what this does is actually runs this particular notebook in this other session, and then brings all the classes and utility functions into the scope. So I can actually use this particular thing in my notebook. And it makes my notebook actually quite simple and easy to work with. And so here, I'm going to load the data of several readings over a period of day. using my utilities. And this sort of gives me back my pandas frame. I'm going to look like what my pandas frame looked like. Well, the shape has got 2,500 rows and it got 10 columns. And then we'll have a look at what it actually looks like. We can actually see that there are 3 readings done during the day, and then it gives me the aggregate power of consumption on that particular day and that particular of that particular year. And we have about entries from 2014 all the way to 2019. And what we want to predict is, given these particular 3 readings or 6 readings, what is going to be my production? And if you look at the distribution of particular data, we can actually see over time. We're probably more interested in figuring out what our mean is going to be. And so here I'm just using my utility functions to get my training data and validation data. And then here's the gist of the experiment that Brooke talked about, is that I'm now going to use 3 different training parameters to train my particular model. And each model will create a new instance of my model. And I'm going to run my MLflow, which will now track all the metrics and do all the runs for me. So let's go ahead and run this. It's very simple. You can actually see that the model over here, this particular experiment, this code is actually quite compact, because all the work that's for the training has actually been delegated to my method called MLflow run. And I get my little metrics to see, oh, this is not bad. The best model probably so far is these 2. So once I've actually done that, how do I actually know which of the models were the best? And as Brooke pointed out, that you can actually go to the MLflow UI to look and compare all the different models. And one of the good things about running this as a managed MLflow is that the UI is part and parcel integrated with the MLflow, managed MLflow. So I'm just going to go over here and then do the runs. And you can see I get a summary of all the runs that I did. Most recent one with 300 estimators and depth in. These are all my metrics that come in. And if I actually wanted to look at further, I can actually go to this particular arrow icon that launches straight into my MLflow UI, which is actually now part of the notebook. If you're running this on an MLflow open source, you would actually run MLflow UI at a port 4040 or wherever you have deployed this, and you would connect to that. But this is actually integrated in the notebook. And you can see that over here, I do get a fairly good sort of tabular format of all the runs that I've done. I can actually do the search of all the experiments that I need. Here's my experiment ID. And I just created by default 1 experiment that had 3 runs in it. And these are my 3 runs that I created. And each of these have the run name associated with the user who created it, the source that was actually used, as Brooke pointed out. There were, what are some of the things that we actually metric. This version over here, because this is not running within the GitHub and I haven't checked in, otherwise I have a Git version of this particular notebook that I actually use. And these are all my parameters, right? These are all my parameters that are specified as part of my constructor that actually came in. If I had more parameters, I would actually all of them over here. And these are the 2 metrics that I actually load. So you can see that right from the get-go, I can actually look at these particular 3. I can say the best 2 models are probably this one and that one, and I can then individually compare them. And I can go over here and click on these and then compare the results. And I see them side by side, right? The max parameters for this were 20 and 15. And I can see that this one actually gave me a better RMSE than the other one. And I can compare my result graphically to see how they actually look like. Or I can go back and look at each and every model. So I can actually go to an individual model, and let's go to this particular model and look at what it looks like. So here are all the stuff that I did. I can actually go ahead and put any notes that I want over here for this particular model. And this is normally what you want to do is save the model. You can see I can't type. And as you go down, you can actually look at the artifacts that I actually created. Now, you actually saw from the screenshot that when you actually click on this, this is where the model artifacts are created. If I look at the MLflow model that Brooke talked about, this is the model flavor that we created. Because we use scikit-learn, it's going to create the scikit-learn version of the particular model, and it will also create a Python function version of the model that you can actually load that using Python environment if you want to deploy this this in a Python environment. It would load that as a PyFunc model, and you can provide a pandas ETL. So every time you actually save a particular model or log a particular model using the API, it creates two flavors. One is the native flavor of the framework that you use, in this case, scikit-learn, that we actually used, and the other one is the Python function. And each of them actually specifies the Conda environment in which you actually created this particular model. So since I trained my model in this, my Databricks environment, and it uses the dependencies that it actually used, so I'm using Python 7.3, I use scikit-learn 20.3, I need pip in order to install that, I used MLflow, and I need the version of Cloud Pickle. So if I wanted to share this or reproduce that in a remote environment, if I wanted to deploy that in a remote environment, then it would know that in order for me to instantiate a version of this model, I need these particular dependencies. And one of the things that MLflow project does is actually take this Conda environment and recreates that so we can actually reproduce in the target environment that we actually created in the development environment. So this is actually quite an interesting concept that Brooke talked about, which deals with how do you reproduce the models, the ones that you created, the ones that you trained, and the one that you're going to share with people to ensure that the model that you train is the same model that you share, right? So now what we're going to do is we're going to go ahead and register the particular model, right? And over here, registering is taking the first version of the model and registering with the central repository. I'm going to go ahead and register model. And I'll just go ahead and create. I don't have the model. I'm just going to go ahead and create. I'm not getting the create button here.
I have one if you want to use it. It has Brooke in the name.
Where is it, Brooke?
Just type in Brooke. Yeah, you can take that one.
So this is going to create a registered model with Brooke in it. Strange, I didn't see the button there. Interesting. All right, so when we go to this particular model, this now is the registered model with the registry. It has, it has the name of the model that actually created. And I can just go ahead and take this model, and one of the things that I actually do is put this particularly the model in production, or I can transition it to any of the stages I do. So I'm going to request this model to be put into production. So I'm going to say, can we into prod? And at this stage, what will happen is that Brooke will come in, since she's the head of the data science group, she's going to say whether I'm going to approve it or reject it. But because of the fact that I'm just being a bit presumptuous over here and telling her to go ahead and put it in production, she's going to come and say, no, let's put this into staging first. So let's do that. And I'm going to go back over here and then transition that to staging. Since I'm allowed to put it in staging, taking Brooke's advice, put into staging.
Hey, Jules, some people are asking if you could just zoom in a little bit on your screen.
Okay, I shall. How about now? Is it better?
Very zoom now.
Okay, so this now actually puts this particular model into staging. So if I go back over here, I can see that I actually have several models in the staging, and the one that we actually just put on the staging is this version number 4. So let's go back to my application, and then I can say one of the things I'm going to do is I'm going to test this particular model against my integration, whereby to see what particular model was actually stored in the registry, and I'm going to load this particular model. Now, one of the things that Brooke talked about is that how do you actually take a particular model which is already in staging, and how do I actually get that particular model so I can actually do the predict functions? One way to do that is to either provide a URI using this particular method, where you can actually provide the staging, and it will give take the model name and give you the latest version of staging, or you can actually just give the version name over here. You can actually do that. So what we're going to do is we're going to take our model name, and our model name over here was Brooke. Do you remember what model name was?
Random forest one.
Yeah, but I think I used it with your.
Oh, sorry. I do not recall.
Okay, hold on. Let's go back here. That was it. Okay, so we're going to go over here, and we're going to change our model name to be that one. And we're going to go down over here and load this particular model over here. This is model number 4. So we're going to load the model number 4. And so what we did was we actually load the model we just particularly registered, and we tried to do the forecasting against what was a staging one, which was the Brooks one, and what was against what was predicted. We can actually see this is not bad, right? They actually tracked pretty much close to what the true value is versus the predicted. So once you've actually done through this experiment, we can go ahead and load more than one particular model version to keep track of all those things, and then we can start integrating that with the forecasting. Once it's actually done, what I can do now is add the description. Now I don't have can do that programmatically, so I can just go ahead and use this particular model version that I have and change that model description. I'm going to change model version to be 4, and then change my description. I'm going to transition now to the production and then use this production model to do the forecasting. And that's actually done. We registered Brooks model. Now this is our model that's actually in production using that. So there were 2 ways I actually interacted with the model registry. One was that I used the UI to go through to ensure that the proper staging was actually maintained in the particular UI. So when you actually went to this particular model registry, you could actually see that. And the other one was using the UI after the CI/CD integration said, okay, we did it in staging. This is the particular version that I think about. I'm going to transition in using the API rather than going back to the UI. So we were able to actually track the different stages the model was in, and we were able to actually do that and deploy it in the particular production. And once you actually done that, you can actually go ahead and delete the models as you want. Now you have to be careful when you delete the model. When you actually delete the model, it wipes out all the metadata and everything. And normally, most people, what they do is they actually they put it in archive and then go ahead and delete it. But we won't go through the stages of deleting the model. I think there are a lot of questions that we actually have that I want to answer before we actually show you anything more. But this, in essence, actually shows you the workflow of how you'd actually use model registry. So let me go back over here and unshare my screen. Okay, that's it. That was a quick demo. Thanks for having the particular model registered. So I was able to register with that particular model. Let's take some questions that we actually have. Let's go from the top.
Sounds good. All right. So first question is, how does MLflow differ from Azure ML Workspace / AWS SageMaker?
Okay, good question. Okay, you want to answer it or you want me to?
No, go ahead. I'll ask questions, you can answer, and I'll chime in later.
Okay. The main difference is that the SageMaker is actually a serving platform, right? So we support that you can actually create, for example, MLlib flavor and then deploy it on the SageMaker using your Docker environment. So we have an ability to actually take your particular model, create a Docker image, and then once you've actually created a Docker image, you can register that with the ECS AWS and then deploy it in the SageMaker. So SageMaker is a deploying platform, whereas it's a serving platform and you can actually deploy it. Whereas MLflow allows you to track the entire model starting from its initial stage all the way to model creation and serving, and then you can actually serve that and deploy it over here. The second question was, what was the second part of the question?
The second part was how it differs from Azure ML as well.
Okay, the Azure ML is, again, a serving platform. We support Azure ML just like we support SageMaker, where you can deploy a Docker image of the model that you actually have on Azure ML. Now, Azure ML is integrated a certain part of the experiment. So if you're using Azure ML, you can use tracking as part of the API if you wanted to use Azure ML just to do tracking and then use the Azure ML to do that. So they are bits similar to what we actually do, but those are sort of two distinct environments. It's just like asking, how is MLflow different from TFX? Well, one is more aimed towards TensorFlow ecosystem and Kubernetes, whereas the other one is more very open manner. You can create models any flavor and then deploy or serve in any of these target environments. Okay, what's the other one?
We have lots of questions, Jules.
Okay.
Could an existing Git repo be transformed into an MLflow project? One may start with defining a Git repo for a project without using MLflow from the very beginning.
Can you? Okay, yeah. I mean, that's a good question. I think one way to actually create an MLflow project without using MLflow is that if you know what your dependencies are, right? So if you know what your Conda environment YAML file looks like, then you just create that particular MLflow Conda environment, and you create an MLflow project file. And in the project file, you provide the entries, and you provide the dependencies, and you create a GitHub, and you provide the code and the data that you actually need. And then you can actually just run MLflow, run with that particular project, and you can do that. The other way to do that, if you actually didn't want to go through the pain to make sure that your dependencies are correct, then you just use MLflow to create the particular model, and then take the MLflow Conda file, and then just use that as part of the MLflow project. The MLflow project, think of MLflow project as nothing really like a Docker environment, or you can think of it as a make file that allows you to create a target environment, which is your model, based on all the dependencies. When you make file, you have things on the left-hand side, things on the right-hand side. It will download everything it actually needs from the appropriate Maven repos, compile it, and then create the target execution. Over here, the MLflow project makes sure that it actually gets the right pip packages that it actually needs from the Docker or from the Conda channel, and then downloads it on the machine and then executes that.
Great. All right, I'll take this next one. How do MLflow projects relate to Onyx? So Onyx is Open Neural Network Exchange. It's kind of like a intermediary format that many different formats support. For example, you could train a PyTorch model, save it to Onyx, and load it from TensorFlow. That's much more analogous to MLflow models than projects. Projects are a way of packaging up your code so you can run it elsewhere. Models are a way of packaging up the model and any of the model dependencies. MLflow actually does support Onyx, so you can always save models with Onyx. But what's nice about MLflow is that it supports way more than just the Onyx ecosystem supports. All right, this question for you, Jules. Any recommendation for hosting the tracking server and the registry server on the same or different machines?
Normally they actually go on the same machine, because tracking server and the model registry store metadata, and all the tracking runs on the same server. So you probably want to have it actually on the same server, right? So that way you have a central place to actually have that. Now it's possible that if you're using the registry as an SQL Alchemy compatible database, the database could actually reside somewhere else, but the URL that you provide could be elsewhere. So in other words, your tracking server is running on one host, but your model registry repositories could be a database that's actually running somewhere else. But you can actually do that, or you can put them on the same host. It doesn't really matter. And one thing good about having a tracking server which is stateless is that you can actually do what we call multiple instances of tracking server. You actually want to scale it, put it behind a load balancer, as long as they all write to the same database, right? Because there's no state actually mentioned again tracking server. When you connect to the tracking server, you're just making a REST call to say, here are my parameters, here's my call, go ahead and load that. And the tracking server knows where my repository is, where my artifact repository is, and where my metadata repository is. And it's just going to load and make a connection to that.
Great. All right, I'll take this next one. For the model registry, how can you embed images into the UI? So in the notes of the model registry itself, you can add images, as Jules had showed when he was writing the description. And then for the tracking UI, you can log any images you want as artifacts.
And just to add to Brooke, yes, in the notes that we actually show in the description, it's editable version of Markdown as well as HTML. So you can put links in there. You can put your entire documentation, and this is a good way to share the history of how the model actually do that. And the artifact and the activity history sort of gives you the provenance of how the model evolved. Remember when I went through the transition period, each and every activity was actually maintained. Brooke rejected it. I made a transition from here to there. Then I made the transition to the production environment. So those are tracked. So you know that you register the model on this particular date by this particular person who was given the permissions, and till the moment you actually deploy it in the production.
All right, next question. Does MLflow provide a standardized REST or gRPC API for model inference, no matter the underlying framework, PyTorch, TensorFlow, et cetera?
Does the model, well, I mean, can you repeat that question again?
Yeah, does MLflow provide a standardized REST or gRPC API for model inference, no matter the underlying framework, PyTorch 10?
Well, the current APIs is standard REST, right? And so if your TensorFlow model is somehow making a connection somewhere else and is using the gRPC, then what we do is when we do a predict function in the native TensorFlow, we're handing off to the predict to the underlying tensor graph method to do the prediction. And if it's using gRPC to make a call to somewhere else, then it will do that. We don't actually dictate that per se.
All right, does MLflow provide an easy way to Dockerize a model, or do I need to write my own code and Docker file to inspect the MLflow format and bake the dependencies into an image?
There are command line tools that takes an existing MLflow model format and convert that into a Docker image for you.
Yep. All right, do MLflow tracking servers support authentication and or role permissions?
Good question. The role-based access control right now is available in the managed version. So in the managed versions, one thing I didn't show you was that you can actually assign permissions based on IAM role. Now, because user provisioning and rollback access control varies from organization to organization, it's not part of the open source. But one way to actually make that actually part of is that you put your tracking server behind a reverse proxy, right? And when you put that, you can actually intercept the call, and then you can make an authentication, say, against an LDAP server to make sure that this user is allowed to execute this particular command, and then hand it off to the tracking server. So that's actually one way to do that. But if you're using MLflow, you get it part of the IAM role. So people in certain groups can manage certain models. People in certain users can manage and edit and do everything in the model registry. So it is part of the managed MLflow, but it's not part of the open source. And one way to make it part of open source is put behind a reverse proxy. I think we would love to. We would love to get contributions from the community to make this standard. Now, SCIM is actually one way to do user authentication. So that way, if your backend is talking Octa, you can talk to Octa. If you're using Active Directory, you can talk to Active Directory. If you're using Kerberos, they can use Kerberos. And so it was a difficult decision to make. How can we actually support across all that? So we are looking into ways that the open source community can actually help that. And this is where you guys come into play, where you can actually say, okay, right now, there's no RBAC involved. Here's my suggestion. Here's my PR request. Do it. If you do it, I'll send you an MLflow t-shirt.
Or mine too.
All right. We would love to hear that. We would love to hear that how you actually use, and even if you actually have successfully done that by putting it behind a reverse proxy, we would love for you to actually share with the community how you actually did that and make that part of the contribution as part of the documentation to say, hey, one way to do RBAC is to use reverse proxy, and this is how we actually implemented that.
In case you can't tell, Jules is our dedicated developer advocate for MLflow and feels very passionate about these topics.
Lovely, lovely.
All right, next two questions, I can take them. Are these functions UI identical and access through Azure Databricks? Yes, yes, they are. And the next question about hyperparameter optimization in MLflow. MLflow doesn't have any native support for hyperparameter optimization, but instead it has integrations with libraries like HyperOpt. So you can have HyperOpt figure out which hyperparameter spaces you can search over, and it automatically gets logged with MLflow. All right, next question. How does the MLflow UI work with models that have different targets? Is it specific to projects? Does it prevent you from comparing models with different targets?
What do you mean by different targets?
I'm a little bit confused. I'm imagining the output label changes, but if that's the case, then that should go under different experiments. Like if you're trying to predict housing prices, then trying to predict fraud, not fraud, those would be two different experiments altogether.
Right. I mean, as Brooke pointed out, I think experiments are like think of the experiment as the directory, and on the directory you have all the different files. And normally those files that you put on the directory are very much related to that particular directory. It's like a source file, utilities will have everything deals with utilities, APIs will have everything with APIs. You can think of experiment as housing price, as she mentioned, and then all the runs in that are housing price. You might have a different experiment experiment where you're doing classification as opposed to regression model. So there'll be actually different experiments. And you can create an experiment by the experiment name and then set the experiment in your MLflow run method in the context over there. And then anything that you log will be logged against that particular experiment.
Yep. And then, yes, it is possible to get the best model run ID using Python code. Next question, can you connect different workflows in something like a DAG? So yeah, you can definitely connect with different workflows. A very common one is using Airflow.
Mm-hmm.
Does the model registry allow for a custom versioning scheme?
Custom versioning are you talking about when we actually register model, do you want to actually create your own version? No, currently actually what we do is when you register a model, if the model doesn't exist, then it will create one for you, and the name has to be unique, just like a directory file within the directory has to be unique. So you're going to create a name of the file, and then any new model that you register against that particular name will have a new version of it. Now you're asking, can you actually change the version name to say version 2.x something, or if you want to have sort of the release connotation of 2.1.3 and 2.1.4. Currently, the underlying data structure version is actually an integer. We are trying to probably implement what we call the string version, so you can actually have the release type of the version. But can you customize it currently? No, you can't.
All right, so follow up, MLflow has a lot of moving parts. Do you have any recommendations on how MLflow can be integrated into existing CI/CD?
One way to integrate with CI/CD is, say, for example, Jenkins. Right? We internally use Jenkins. The good thing about integrating with all these different integration tools is they use the MLflow client API to be able to actually get the stuff you that. So, for example, I showed you I registered the model with my MLflow registry, and my forecasting application could be part of Jenkins, or could be part of Circle AI, or could be part of GitHub that actually checks out a particular model, right? And the way we checked out the model I showed was that you provide the model URI with the name of the model and the version number, and it goes to the registry and picks up the particular model that you want. So yes, you can actually integrate with all these existing CI/CD tools through APIs. There is no sort of like a plugin. What you do is you use the APIs to connect to the registry to check in, check out. So you think of it, the CI/CD tools, as a consumer of the registry to pick up the models that they actually need. And the CI/CD tool could also be reviewers who could actually check out a particular model and say, okay, I ran this particular test and everything ran fine. I loaded the version 2 and version 3 to do my A/B testing, and I thought that version 2 was better than version 1. So I'm going to now transition that either using the API or using the UI. And we showed you how you can actually make those transitions. So the API is the really drug for developers. They love APIs. If I can do everything in APIs, I wouldn't even use a notebook. Sorry, Brooke, but I would just use PyCharm to do everything.
All right, so next question. I know we can get the latest versions of the model for an experiment using the model registry, but can we also search for model versions by filters? Is there a way to combine the two, e.g. get the latest version of models in experiment 5 and filter by metrics.rmse greater than 0.1?
Yes, what you can do, we actually have an entire search API associated with registry. You can actually search by experiment, and when you do a search by experiment, what you get is you actually get an entire data frame that has all the runs on it. Or you can actually just do a get the latest version of the model and then pick up the latest one that you actually need, right? So yes, you can actually filter things out. You can actually do that.
All right, and then we have quite a few questions asking about how does MLflow compare with Kubeflow?
The only thing, the only comparison is that they have the same suffix. No, I mean, levity aside, I think Kubeflow is more aimed towards doing the orchestration of the TensorFlow model on Kubernetes, right? Whereas MLflow sort of gives you an end-to-end way to actually manage cycles from the beginning in addressing all the challenges that you actually have in developing the model all the way to managing the model, and then finally, eventually putting it to production and serving. So I think those are sort of two different things. The only thing common, as I said, is they have the same suffix.
All right, and then I'll take this next one.
Mm-hmm.
How do you, or how does MLflow deal when the data set changes, and what are your suggestions for that specific scenario? That's a very common case. Every day you get a nightly dump of data. If I train a model today, I train a model tomorrow, and I change the hyperparameters, did the model do better because the data changed or because of the hyperparameter change? And so we often recommend that you version your data using Delta Lake. Mm-hmm. It's an open format, which allows you to do time travel with your data, rollbacks, etc. And so you can integrate Delta Lake with MLflow. You can log the version of the Delta Lake table you're querying from. You can log the timestamp and then go back in time based off of the timestamp. So that's our suggestion for dealing when data sets change. Otherwise, you're not comparing apples to apples if the underlying data is changing. One other alternative is you can always log the data itself as an artifact. It's very expensive to do that, but that is an option. That way you can snapshot the entire data.
Or the alternative, you actually don't want to do it with the expense of that, then instead of actually logging the entire artifact, what you do is you should log that path to the artifact location. Let's say you're versioning data in the directory structure on S3, and you train this particular model with that particular directory path, then you just load that directory path. And the next time when you want to load the model, you just load that using that particular training data. But the best way to do that, as Brooke pointed out, is using Delta, because that manages everything for you. It gives you the time travel, it gives you the versioning, and it's integrated with MLflow already.
Yeah, I mean, if you log the directory, you could always have that sneaky intern that goes in and updates your code and you wouldn't know. Mm-hmm. So while that would be the cheapest option, it's not the most bulletproof option.
Yes, it's brittle because somebody can change the directory structure, or somebody can mount it a different place and boom, you're gone. Your data is.
Yep. All right, and then question, do you provide Databricks platform for students? We actually have a free Databricks offering called Community Edition. I'll drop the link in here in a second. Anybody can sign up for it. You can use MLflow there, etc. Model registry is not enabled there. But you can use the tracking APIs, etc. And then people are asking for your code, Jules. We shared out, yeah, and Delta Lake. And then let's call this the very last question of the day. How to migrate from Data Lake and Hadoop to the Delta Lake?
How do you migrate Data Lake? I think it would be a good question for our Delta Lake advocates to do that, but you want to take your Hadoop data lake and migrate it into data lake. The first thing you actually would want to do is you want to convert all the data lake into a Parquet format. And once you actually have a Parquet format, it's very easy to ingest that into Delta Lake, because Delta Lake by default supports Parquet. So if all your data in Hadoop is in Parquet, just loading them into Delta Lake would be an easy task. But if all your data in Delta Lake HDFS is in a different format, then you might want to convert that into Parquet and then use Delta Lake.
Great. I'm just sharing all the links here, Delta Lake docs. And then the last thing that we wanted to end on was just what resources you can access going forward. So let me share this tab. Where to go next? You can get started by installing MLflow with pip install MLflow. Find docs and examples at mlflow.org. Check out the code, contribute to MLflow with GitHub, join the Slack channel, it's very active, and then you can see lots of MLflow tutorials from Jules.
Yeah, and if you have any specific questions that we couldn't answer because of the time or anything, just send mail to Brooke and me. Do you want to put up our email address? It's already on the slides.
I actually think we forgot it from the slides.
Okay, just Jules at Databricks, and I'm just going to put my name here.
And I'll put mine as well. One of the benefits of Jules and I being at Databricks for many years, we both have first name at databricks.com.
So yeah, she just sent a mail, Jules, or connect with me on LinkedIn, or follow me on Twitter, and I'll follow you. I know that sounds a bit dodgy, but I mean I'll follow you on your Twitter handle. And yeah, just connect with me. And when you send a LinkedIn request, just tell me that you attended this session so I know who you are. And then if you have any follow-up questions, I'm more than happy to answer those for you. And please start looking at the MLflow.org for some of the issues. If you think something that is actually missing that you would like to see it, file it as an issue. If you think that you want to contribute something passionately about it, please go ahead and file a PR request. I'm the guy who's doing all the triage, so I'll make sure that that it gets addressed as soon as possible. And this is the coveted T-shirt.
Yes, and there's also women's cut T-shirts as well. And then one last thing, there are lots of new advancements coming with MLflow, for example, auto logging. And we're always looking for more people to contribute. For example, scikit-learn, we need a lot more contributors to help out with that. We have a pretty stable one with TensorFlow, but always looking for more contributors.
And just to add something what Bruce said, yeah, the auto logging allows you the ability to auto log everything automatically. So if I had the auto logging working already in scikit-learn, there's a PR request on it, I wouldn't have to say log parameters. I wouldn't have to say log metric. I wouldn't have to say log artifact. I have just one line of code, scikit-learn.autolog, and it will automatically keep track of all the metrics that is computed, all the artifacts that I created, all the model parameters, and it will log that automatically for you. So your code becomes very succinct. Your code becomes very short.
Yep. And then last question is about how we're sharing the slides. The GitHub repo is public. We've already posted the link there. I actually don't know the answer for how these slides are getting shared. I'm not sure if that's through the organizers.
What we can do is we can actually upload on the GitHub link and share.
Oh, perfect. Upload the PDF.
Yeah, upload the PDF on LinkedIn SlideShare, and then we can just give it to Diana or Tina, and then she can share it with the rest of them.
Great. Well, we are exactly at time now. Thanks, everyone, for staying tuned, learning more about MLflow, and looking forward to seeing all of your contributions.
Well, thanks a lot for attending, and hoping to be connected with you on virtually everywhere. And thanks a lot. Bye.
Thanks, everyone. Bye.